Hey guys, today I want to talk about subnetting. I hope that this explanation doesn't get boring to you. I promise you that I will explain it in a very good way that you will really understand what is subnetting, because I have seen that some people they have problems with subnetting and I want to explain it to you. It's really not complicated. The first thing that you should remember, do not go inside the details of binary subnetting and these kind of things, because they really make the situation complicated for you if you are not really good expert and if you are really not good technically good in computer network engineering. Subnetting is the process of splitting one internet protocol into the sub network addresses. What does it mean? We have IP address. You better know it that we have class A, we have class B, we have class C. The class A is starting from 1 to 127, 127. What does it mean, 127? What does it mean it's starting from 1 to 127? This is very important to know that what does it mean from 1 to 127? What is this? How do I know that it's class A, or how do I know that it's class B, or it's not a class B IP address? Because we have a solution for it. And I tell you why. Because an IP address is a 32 bits address that is split into 4 octets. An IP address is 32 bits and it's split into 4 octets. What does it mean, 4 octets? I start drawing a line from here and I split it 4 times. 1, 2, 3, 4. Inside these 4 places that I have, 4 dots that I have splitted, there are 8 bits. 8, 8, 8. 8 multiplied by 4 is equal to 32 bits address. An IP is 32 bits address. And how do I know that if this IP is belonging into the class A or class B or class C or class E or class D? We know it from the first octet. That's why I wanted to talk about octets to you. Class A IP address is the first octet is starting from 1 to 127. When the first octet of the IP address is starting from 1 up to 127, it means that the first octet is between these numbers, then you should immediately know that it's a class A IP address. And today I want to work an example of a class A IP address subnetting. Guess that, suppose that you have got a question, an IP address like 10.5.2.1. Yeah, you have the IP address of 10. Oh, it's not. Zero. You have the IP address of 10.5.2.1. I hope I can capture it. Yes, I can. We have the IP address of 10.5.2.1, and we want 6 networks from this address. Okay, and then we write down the broadcast addresses. And when you have the network addresses, the host addresses, they come automatically. You don't need to be worried about it. The first very important thing that we should know is the network addresses, because you set the network addresses into the routers of your company or into the switch into the different LANs. Understand? Okay, we need 6 network addresses. 6 network addresses. I will split it for you now. The second thing that you should know, that when you want to get 6 network addresses, I will tell you something. In every class of IP address that you are manipulating with it, or you want to make the subnetting, the first octet of the, because we are on class A, the first octet of the class A is standard. We can't change it, we can't touch it. We just jump into the second octet. We borrowed the bits from the second octet, from this octet. We borrow bits. We have 8 bits here. How do we know that we have 8 bits here? Now I show you. It's very easy. I don't make it complicated for you. You also don't make it complicated for you. It's very easy. I show you a method that you should use it. The first thing that you see that you get an IP address 10.5.2.1 and you need to split 6 network or 8 network or 20 network or whatever, then you use this method. Write down quickly 1, 2, 4, 8, and double it. Double it till you get 128. Okay, 16, 32, 64, 128. Now split each one from each another one like this. Then we write down here under each of it 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7. Okay? Good. Now, when we have written this one, we need 6 network addresses from this IP address. When we need 6 network addresses, we use our formula n to the power of bits. This is the formula, n to the power of bits. How many bits we should get, or how many bits we should borrow. We see that if we get, in the first bit, we have 2 to the power of 0 is always 0. Cross it, always, because it's 0, you can't do anything with it. 2 to the power of 1 is 2. It means that you can get only one network address. 2 to the power of 2 is 4. You can get 4 network addresses. That one of them will be broadcast address, one of them will be multicast address, and you will get only 2 addresses. It's not enough. When it's not enough, because we need 6 addresses, we jump and we come to another one. 2 to the power of 3 is 8. Now we have 8 addresses here. It means that if we borrow 3 bits here, understand, if we borrow 3 bits here, now we can get Now we can get 8 network addresses we get our 6 network address and the rest we don't need it. They will go into the broadcast address and multicast address and these things, and if we have more than enough and we have enough more, we don't need it. We just get what we want. If you are less than this, you can't make subnetting. If you are more than this, you have more facility, you have more abilities, but you just let it like this, okay? Now, we gated 3 bits, okay? When we get 3 bits, then we have network addresses, 8 network addresses, and we just write down our IP address. That's the only thing that we can do. Just write down our, the first IP address will be 10 dot 8 dot 0 dot 0. The second IP network address will be 10 dot. We double the what we have borrowed. We double the 8. 8 plus 8 is 16. 0.0. The third IP address will be 10 dot 16 plus 8, 24. 24.0.0. The fourth IP address will be 10 dot 32. 32.0.0. The fifth IP address will be 10.40.0.0. And each time you double it, and next time, for example, the next IP address will be the next IP address will be 10.48.0.0. See? It's not that difficult, I think. Now we have 1, 2, 3, 4, 5, 6. We got our 6 network addresses. We don't care about the rest. We just let it to be. Because what we wanted, we got it. These are our network addresses, okay? Now, what about the broadcast addresses? The broadcast addresses in here, I wanted to show you how you can find out the broadcast addresses here. The first one, don't worry about that one. The first one, just let it to be like that. The second one, come to the second one, this one. The broadcast address for this is 10 dot 15 dot 255 dot 255. This is the broadcast address. It means that this is the broadcast address between these 2 IPs. The broadcast address in here is 10 dot 23 dot 255 dot 255. How can you get the broadcast address in each IP that you are coming and you are seeing? For example, here it's 16. You should know that 15, between this and this IP address, between 8 and 16, the last number of the IP address before you start your network address is the broadcast address for you. For example, between 16 and 24, the last number of IP address before I get my network address, before I double it, it is the broadcast address. In here, the 23 is the broadcast address. In here, the 31 is the broadcast address. 10.31 dot this dot this. This is not one, this is just a vector. In here it's the 39, and in the last IP it's the 47. Understand? Now this will be solved. This problem is solved. We found out what is going on, and now I want to tell you about the default gateway. What is the? I want to show you how to find out the subnet masks for the whole bunch of IP. The subnet mask, we borrowed 8 bits here. When we borrowed, 8 bits I said, we borrowed 3 bits here. When we borrow 3 bits, then we just calculate the left side of the bits and we write down our subnet mask. 64 plus 1, 2, I need a, what is that? I think it's, I think it will be, a lot of time I'm just not good with this mathematics and these kind of things, and that's why I need to use the calculator. The subnet mask for this IP will be 255 dot, because it's a class A, okay, I said that normally the class A subnet mask is 255.0.0.0. Yeah? Yes, that's right. But when you make the subnetting, after subnetting, you should find out the subnet mask in different way. You first of all, you write down, as we didn't even care about the first part of the first octet of the IP. In here also the first octet of the subnet mask stays the same, 255. The second octet of the subnet mask, we let the side that we borrow, we let it to be, we don't touch it, we don't care about it, and we jump into the left side of the bits and we calculate them. We add them with each other, and then we write down the sum of this. 128 plus 64 plus 32. I'm sure that you have already calculated, guys. 32 plus 16. 240. 240.0.0. This is the subnet mask address for each one of these IP addresses that you can use in your networks. I hope that you have understood it, and thank you very much for the attention, and have a good luck. Bye.